As we go through all these examples for the product rule, notice that the notation keeps changing. I want you to be aware of all the different ways of doing notation for derivatives. So here we want to take the derivative of the expression with respect to t. Because when I look at this expression I see two clear parts to it, that can be considered one function. This could be considered one function. I break this down and say let u equal t minus 4 to the third and v equal t plus 9 to the seventh. I take a derivative with respect to each function. Power rule here, 3 times t minus 4 raised to the second. Power rule for the second part, 7 times t plus 9 raised to the sixth. As I look at this being dy dt, we would say u times dv plus v times du. I substitute those respective values in. And notice that this one gets pretty large here. We've got all kinds of terms. But as I look at the terms, I notice that there's a great similarity from each part. You see this series of products, this series of products. There's so much in common that I'm going to pull out what they have in common. In other words, I can pull out a t minus 4 raised to the second from each one of these terms. I can pull out a t plus 9 raised to the sixth from each one of these terms. And as I do that, here's my t minus 4 to the second, t plus 9 to the sixth. It leaves me with 7 times t minus 4 from this first series of terms, and it leaves me with 3 times t plus 9 from the second series of terms. What's in the brackets can then be distributed, and I can combine like terms. As I do that, I have 7t minus 28 plus 3t plus 27. Just simplifying those, I can end up with a series of products. And so I have dy dt equaling t minus 4 raised to the second, t plus 9 to the sixth. That was the common denominator of all those terms. And then as I simplify the bracket, it goes to 10t minus 1. That would be our derivative in simplest form.